So in chapter 3, we're going to be talking about shorthand differentiation rules. This is a big chapter. It's going to cover a lot of territory. Almost all of it has to do with developing differentiation techniques. The first one in 3.1 has to do with what we call the power rule and the exponential rule, that is the base e exponential, e to the x. So in these two forms, where you have a polynomial expression, cx to the n, or in an exponential where you have y equals c e to the x, where c is a constant, y prime for the power rule is n times c times x to the n minus 1. And for the exponential, y prime is equal to c e to the x. The exponential rule here, that is the base e exponential, is that e to the x is very convenient because it's its own derivative. An example of each of these then is going to be for the power rule. If we have something like y is equal to 2 times the cube root of x squared plus 4x squared minus 3e to the x plus 6, okay? Now, in order to use the power rule, you want to make sure that every variable is in exponential form. Notice that the first term here, 6 times the cube root of x squared, is not in exponential form. So what I'm going to do first is put this into exponential form. This should always be your first step, by the way. So this is going to be y equals 2 times x to the 2/3 power plus 4x squared minus 3e to the x plus 6. And by the way, the other thing that you don't see here is that the derivative of a constant is equal to 0. Because a constant is not changing. There's no variable with it. So therefore, its rate of change is 0. That's why the derivative is equal to 0. So therefore, y prime for this expression is equal to 4/3 x to the 2/3 minus 1, which is negative 1/3, plus 8x minus 3e to the x plus 0, but of course I'm not going to write the plus 0 because the derivative of the 6 is equal to 0. So here's your y prime. You might also want to make sure that you understand how to go from radical form into exponential form, and also be able to go from exponential form back into radical form. That will be important in solving derivatives when we get to the first derivative test. Okay, so in a nutshell, this is really the essence of 3.1. Now in 3.2, we cover the two rules. First one being the product rule, which is where we have the product of two functions. And the second one is the quotient rule, where we have the quotient of two functions. So let's take a look at each of those. Now, what I'll do first, before I actually go through these examples, is I'm going to tell you exactly, because it's in the book, what each of them are. the product rule, where we have two functions that are multiplied together. First function and second function. So derivative by product rule is the first times the derivative of the second plus the second times the derivative of the first. An example of that. Again, we'll use a simple example here. So let's say we have the function y is equal to x squared times e to the x. All right, that's the product of two functions. First one is x squared, second one is e to the x. Okay, nice, simple product of two functions. So remember what I just said, first times the derivative of the second plus the second times the derivative of the first. And when I'm done with this, if there's any factoring to be done, you should also perform any factoring. You want to get into the habit of that, even though WebAssign may accept it. When you go to check your answers in the back of the textbook for certain problems, you're probably going to find that a lot of these are in factored form. So let's take a look at this. So y prime is equal to the first times the derivative of e to the x, which is e to the x, plus the second, which is e to the x, times the derivative of the first, which is 2x. Now, this is what I refer to as the raw derivative, okay? That means right after we have applied the product rule, this is what it looks like. But notice that I haven't done any factoring yet. It's important that you factor this completely, because when we get to the first derivative test and the second derivative test, you must be able to factor these in order to solve. So my second step here is to perform any kind of factoring that is common factors are factored out completely. So I have y prime is equal to x times e to the x times x plus 2. Now, more than likely, when you use either WebAssign or when you look in the back of the book for the answers to certain problems, you're going to see it in factored form. And also, it's going to be essential when we get to the first and the second derivative test. You must be able to do this. And I'm going to require this on exams. Okay? That's the product rule. Now let's take a look at an example of the quotient rule. And once again, like I did with the product rule, I will first read this to you. Clearly, it's in the book. I'm going to have it right in front of you. If you're watching these videos, which you should be. If you have a quotient of two functions, one function divided by the other, it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. So again, these are in the book, and you should have them written down in front of you. So let's take a look at an example of a quotient rule. Again, I'm going to pick something easy here. Okay, let's try 3x squared divided by 2e to the x. Now, notice right now we have a limited number of functions that we can work with because we haven't dealt with the other exponential yet. We also haven't dealt with natural log functions or base B log functions, and we haven't dealt with any of the trig functions yet. So here's a quotient. One function divided by the other. Now remember what I just said, we start with the denominator. Run through this, and then once again, when I'm done with this, your final answer should be in factored form, but not only in factored form, but it should be reduced if that is possible. You've got to get into the habit of doing that. Algebra is the killer in calculus. So I have y prime is equal to the denominator 2e to the x times the derivative of the denominator, which is 6x, minus the numerator, which is 3x squared, times the derivative of the denominator, which is 2e to the x. And that's all divided by the denominator squared, which is 2e to the x squared. Now, again, I'm going to use the same language. This is the raw derivative. This is what it looks like right after you have applied the quotient rule. But notice how ugly that is. Ugly meaning that you're not going to be able to solve this if this were a first or second derivative test. So I'm going to factor this numerator, and then I'm going to reduce this to its lowest terms, which, by the way, you should always do. Okay, so I have y prime is equal to, I have 3x times 2e to the x times 2 minus x. All divided by, once again, the denominator squared. All right, I'll show you this. Now that my numerator is completely factored. Okay, so my numerator is completely factored now. And notice that there's a common term, the 2e to the x. There's 1 in the numerator, there's 2 in the denominator, so I can reduce this by canceling one of them out. Make sure you understand your basic algebra rules here of what you can cancel and what you can't cancel. Don't want to make any silly algebra, basic algebra mistakes. So y prime is equal to 3x times 2 minus x over 2e to the x. Check. That's my final answer. Okay. Notice how nice and clean that is, and especially if this were part of a first or second derivative test, how easy that would be to solve as opposed to the raw derivative. You must get into the habit of practicing this kind of factoring and reducing wherever possible. Okay. So I'm going to send out an email right after I get done with this. These will be available to you. I'll start making these for chapter 3. Chapter 3 is a long chapter. I'll start making more of them tomorrow. Okay. Stop the recording.